Welcome students to this third video on Opamp in Electronics with Expert. In this video, I will discuss you about input resistance, output resistance, input offset voltage, input offset current, input bias current and CMRR of a practical op-amp such as an IC741. So let's start the video. So number one is the input resistance. Input resistance, that is denoted by Ri. It is the equivalent resistance that can be measured at either the inverting or the non-inverting input terminal with the other terminal connected to ground. So input resistance is the resistance that actually opposes the input current to flow into the op-amp. And as you know, for an ideal op-amp, the value of the input resistance is about infinity, but for IC741C, the input resistance is about 2 mega ohm. The next parameter is output resistance R0. It is the equivalent resistance that can be measured between the output terminal of the op-amp and the ground. And for an ideal op-amp, as you know, the output impedance or the output resistance is 0, but for IC741C, the output resistance value is about 75 ohms. The next parameter is input offset voltage VI0. It is the voltage that must be applied between the inverting and non-inverting input terminals such that the output is nil or 0. It is denoted by VI0. For 741C, the maximum value of VI0 is about 6 millivolt. Now, smaller the value of VI0, that means the better the input terminals are matched. And this input offset voltage depends on temperature. Now, the fourth parameter is input offset current, that is denoted by II0. Now, to discuss about II0, let's consider IB1. IB1 is the input bias current which flows along the non-inverting terminal, and IB2 is the input current at the inverting terminal. Now, input offset current is basically II0, and this is represented by the value, that is the algebraic difference of IB1 and IB2. Now, the magnitude of this current is very small, of the order of 20 to 60 nanoampere for 741C. The fifth parameter is input bias current, and it is mathematically represented by IB. IB is the average of the current that flows into the inverting and non-inverting input terminals of the op-amp. That is, it is the average of IB1 and IB2. So IB can be represented as IB1 plus IB2 whole divided by 2. And in case of 741, the value of IB is about 500 nanoamperes.
In my previous video, I have already discussed about the common mode rejection ratio, what will be its value for an ideal op-amp and what is the value for a real op-amp. But in this video, I will discuss about CMRR in detail. As you can see that V1 is the input voltage at the non-inverting terminal and V2 is the input voltage at the inverting terminal. Now, in practice, the difference signal Vd and the average signal, that is the common mode signal Vc, are amplified to produce the output voltage V0. Now, what is Vd? That is the difference voltage Vd can be written as V1 minus V2, and as well as the common mode voltage Vc, it is average of V1 and V2. So difference voltage Vd equals to V1 minus V2 and Vc equals to V1 plus V2 by 2. We have V0, that is the output voltage, it is equals to A1 into V1 plus A2 into V2. Now where A1 is the voltage gain when the other terminal, that is the inverting terminal, is grounded, and A2 is the voltage gain when the non-inverting terminal is grounded. Let's denote this equation as equation 1. Now V1 can be written as Vc plus half of Vd, let it be equation 2, and V2 can be written as Vc minus half of Vd, and let it be equation 3. Substituting the values of V1 and V2, that is from equations 2 and 3 in equation 1, we get V0 equals to half A1 minus A2 into Vd plus A1 plus A2 into Vc, that can be written as AD Vd plus AC Vc, and let it be equation 4, where AD equals to half A1 minus A2 and AC equals to A1 plus A2. Now AD is the voltage gain, that is the differential gain, that is the voltage gain for the difference signal, and AC is that for the common mode signal. In the ideal case, as you know that AD is infinitely large while AC is 0. In practice, the situation is not really ideal, and that's why a figure of merit called the common mode rejection ratio, or in short CMRR, of the op-amp has to be introduced. CMRR is defined as CMRR equals to mod of AD by AC. Since AD needs to be very large and AC very small, the amplifier must be so designed that the CMRR is much larger than unity. So for an ideal op-amp, that value of CMRR is actually taken as infinite, where obviously for IC 741 it is a large value but should be finite. To know about op-amp basic structure and block diagram and differences between the ideal and practical characteristics of an op-amp, you can watch these two videos in my channel Electronics with Expert. If you have any doubts in this video, you can comment in the comment section. Thank you and see you soon.